Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? So here we have to evaluate this integral which is from 0 to pi by 2, and here we have cos x divided by cos x over 2 plus sin x over 2 raised to power 3, right? So here we'll try to evaluate this integral, and let us call this integral as I, right? Now here we see that our integrand is a trigonometric function, right? So here in the numerator we have cosine x, and in the denominator we have the combination of cosine function and sine function, right? So in such problems what we usually do, we try to use some important trigonometric identities to simplify the integrand, right? So here we cannot directly make use of the method of substitution. Rather, what we will do, we'll first try to recall some important trigonometric identities which can simplify this integrand, right? So let us start. So here what we will do, we'll first make use of this identity, that is cosine x, right? Now see, we know that cos 2x is equal to 2 cos square x minus 1, right? And if we write the half angle formula from here, then we see that we have cos x is equal to 2 cos square x over 2 minus 1, right? And now if we take this negative sign to this side, we'll have 1 plus cos x is equal to 2 times cosine square x over 2, right? So here we have this identity for cosine x, and the other identity for cosine x is we know that cos of 2x is equal to cos square x minus sine square x, right? And again, if we write the half angle formula from here, we see that we can write cos of x is equal to cos square x over 2 minus sine square x over 2, right? So here we have to use this identity in this integral, right? So here we have cos of x, so we can write cos of x is equal to cosine square x over 2 minus sine square x over 2, right? So we have also here mentioned this identity, but we cannot use this identity here, right? So now let us apply this identity over here. So we have I is equal to 0 to pi by 2, and for cos x we can write cos square x over 2 minus sine square x over 2 divided by cos x over 2 plus sine x over 2, right? And here we have cube, right? Okay, so now in the numerator we have the term that is a square minus b square, right? So we can now here use a minus b, a plus b. So now we can write this integral as 0 to pi by 2 cos x over 2 minus sine x over 2, and then we have the term a plus b, so we have cos x over 2 plus sine x over 2 divided by cos x over 2 plus sine x over 2 whole cube, right? And here we have dx, right? So now we see that here this term and one power get cancelled, so here we are left with 2, right? So now we have 0 to pi by 2, and we have cos x over 2 minus sine x over 2 dx divided by cos x over 2 plus sin x over 2 whole square, right? So once we have used this identity here, now from this step onward we can make use of the method of substitution, right? So now if we substitute, say t is equal to sine x over 2 plus cos x over 2, then we see that dt over dx is equal to half the derivative of sine x by 2 is cos x over 2, and here we have minus half sine x over 2, right? So the derivative of cosine function is negative and the half factor is due to the chain rule, right? So now we can write half cos x over 2 minus sine x over 2. So dt can now be written as, or 2 dt can be written as cos x over 2 minus sine x over 2 dx, right? So now for this term we have 2 dt, right? And for the denominator we can now write t square here, right? Okay, so now here we see that x varies from 0 to pi by 2. So when x is equal to 0, because since we are using the substitution method and we are introducing the variable t, so let us change the limits accordingly, right? So when x is equal to 0, t is equal to, here we have sine 0, and then here we have cos of 0, because we'll take x is equal to 0 over here. So we have 0 plus 1, that is 1, right? And when x is pi by 2, we have t is equal to sine. Here we'll take x is equal to pi by 2, so this is pi by 4. This pi by 2 is multiplied in the denominator by 2, and here we have cos pi by 4, right? And sine pi by 4 is 1 over root 2. This is 1 over root 2. This is 2 over root 2. And if we rationalize it, we'll have 2 root 2 over 2. So 2 and 2 get cancelled. So we are left with square root of 2, right? So now when x varies from 0 to pi by 2, then t it varies from 1 to t is equal to square root of 2, right? So now we can write our integral I as integral from 1 to square root of 2, and for cos x by 2 minus sin x by 2 dx we have 2 dt, and for this term, that is we have t square, right? Okay, so now we can take 2 outside, so we have 1 to square root of 2 and t raised to minus 2 dt, right? And the integral of t raised to minus 2 is t raised to minus 2 plus 1 over minus 2 plus 1, and limits are from 1 to square root of 2, right? So here we have used this result, that is integral of x raised to n, where n is any number except minus 1. So this is x raised to n plus 1 over n plus 1, right? So in this case n is equal to minus 2, right? So now we have 2 here, and we have t raised to minus 1 over minus 1 and 1 to square root of 2, right? So now we can simplify it. So we can take this negative sign outside. So we have minus 2 and 1 over t, and the limits are from 1 to square root of 2, right? So now we'll substitute the limits and we'll take the difference. So 1 over root 2 minus 1 over 1, right? So this expression can also be written as 2 we can multiply these two terms by this negative sign, so we have 1 minus 1 over root 2, and then we can here multiply these two terms by 2, so we have 2 minus 2 over root 2, and we can rationalize here, so we have 2 over root 2 times root 2 over root 2. So this is 2 minus 2 root 2 over 2. 2 and 2 get cancelled, so we are left with 2 minus root 2, right? So viewers, the value of this integral is equal to 2 minus square root of 2.